Hi and welcome to Train Signal. We're continuing our discussion of Hyper-V failover clustering logic, taking a brief diversion over into a product called System Center Virtual Machine Manager. This is a whole separate product, separate from the Windows OS itself, but is a useful add-on to be able to help support Hyper-V failover clusters, Hyper-V servers all by themselves. It can even be used to manage non-Microsoft virtualization platforms like VMware and Citrix. One of its most interesting characteristics from Microsoft's perspective just at the moment is its critical role in Microsoft's vision for what's called the cloud. Now you may have heard this buzzword thrown around here and there and wondered, what is it? Truth be told, there's not a lot of agreement about what it means exactly. A lot of people use cloud to mean a variety of things. Some people will say, hey, I've got a cloud, when they really mean they've got a web-based application. Cloud technology can be web-based, but not necessarily exclusively so. My favorite way of thinking about what a cloud is a way of taking all of the services that an IT organization ordinarily provides and being able to access it either in a self-service sort of a way internally within a company, that'll be a private cloud scenario, or perhaps with the help of some internet-enabled third-party vendor. Consider the reasons for which you might go call IT. You want to be able to go create a new server because your department has a new application that they want to roll out. Well, ordinarily, you'll talk to somebody, and that person will kind of get your specifications and try to help brainstorm what sort of server is going to be best for that sort of an application. Then we'll start the purchasing process and acquire some hardware and get it configured with an operating system and configure it to company specs and all those sorts of things, and then put it in your hands to go install your application. But imagine that we take that same request, target it either at an internal resource or at some third-party company, and in response to the request, hey, I need a server, it needs to be about this capable for this sort of an application. And your provider says, oh, that's easy. We're just going to create a virtual machine for you and deploy it. It'll be accessible in the network in about another 3.5 minutes or so. It's an idea called infrastructure as a service, and it's one of the defining characteristics of the SCVMM product. With SCVMM, we're going to be able to support a variety of different virtualization platforms, not only Microsoft virtualization, but those that are provided by other vendors like VMware. In SCVMM's terminology, what we're managing are hosts. The term that Microsoft uses, the VMware uses, the Citrix uses for their equipment doesn't matter quite so much. From SCVMM's perspective, they're all hosts. If they provide some sort of a clustering or grouping or collaboration technology amongst those servers, they are then part of a host group. On those hosts, or to those host groups, we'll then deploy virtual machines. Those virtual machines can be created manually, of course, but they can also be created with the help of something called a virtual machine template. The template helps drive a certain degree of standardization into the way we deploy VMs in our environment by letting a new application be deployed on a standard small VM with a fairly small amount of RAM and a fairly small amount of storage and a fairly small amount of processor capability, or to a medium-sized server, or to a large-sized server. And I get to define the templates, the basic kinds of VMs that somebody can deploy on my SCVMM environment, and in turn, therefore, on my Hyper-V or my VMware environment. SCVMM implements a virtual machine library, where if a virtual machine is not being used on my host, and won't be for a while, imagine, for example, that we have an accounting application. It runs once quarterly for a couple of days, and then we shut it down. We don't need it again until 3 months later. Well, that used to be a physical server here at GlobalMatics. Used to sit in the corner and do nothing for 2.5 months out of 3, and then we'd turn it on and it would spin up and it would do work for a couple of weeks, and then that quarterly tax processing event was done, and we'd shut the server down and it would just sit there collecting dust for another 2.5 months. That's obviously not ideal, but when you're using physical hardware, there's not a lot that you can do. But when it's a virtual machine, it's just a bunch of files. And in SCVMM, I can migrate that virtual machine into my virtual machine library, moved to probably cheaper, less fast-moving storage, where it sits and waits until the time that it's called upon and gets moved back into a production environment, moved back onto a host. If you scale up from that idea of virtual machines and virtual machine templates, consider that there are a number of scenarios where a company will routinely roll out a similar collection of servers for various purposes. There are a lot of times where you'll need some number of web servers on a front end, and then some database servers on a back end, and some middle tier servers for application logic in the middle. And we might see that same pattern of half a dozen or 8 or 9 servers rolling out again and again for different applications that our organization provides through IT. In the SCVMM world, those are called services. A service is a collection of VMs deployed together to provide support for some particular application. And I can build service templates that describe them. SCVMM supports P2V, physical to virtual conversions. I can analyze a physical computer running some older application. Globomantics has this one application written back in 1990 something. It's running on an NT4 computer, and the people in the office refuse to upgrade the OS. Why? Because the vendor says that it runs on NT4. And we tried to talk to the vendor that wrote the software, but they went out of business back in 2003. There's never going to be another new version of the application. The people who run the application insist that it must remain running, but it's on this NT4 OS. Well, here's a good idea. Let's virtualize it. Let's create a virtual machine that contains that exact same content, including the OS, and run it in a virtual machine instead. Physical hardware is going to break one day. Virtual hardware doesn't rust. V2V is conversion of a virtual machine to a virtual machine. Well, what are they talking about there? That's actually conversion of VMware virtual machines to Microsoft virtual machines. Strangely enough, Microsoft doesn't provide a way to go back in the other direction. Go figure. So let's see what happens when I take my SCVMM environment and point it at my Hyper-V failover cluster. So here I am on Globomantics' SCVMM server. At the moment, it's just installed. The database, SQL Server database that underlies this is entirely empty. Let me start the process of managing my environment using this by visiting the VMs and Services portion of the interface, visiting the list of hosts, and preparing to add a new Hyper-V host. Note that I can roll out Hyper-V hosts, I can roll out Zen server hosts, I can roll out ESX hosts, and all those can be managed from SCVMM. In this case, of course, though, we've got Hyper-V. This is a Microsoft course. And it wants to know, where are the computers that I want to be able to manage? These computers are in a trusted Active Directory domain. This computer is a part of the globomantics.local ADDS domain. Alternatively, I've got other places I could go search for a computer. I could go search some domain that's not part of my Active Directory environment. I could go search the DMZ. I can start the process of provisioning a bare metal computer, identifying that I intend to set up a computer that will become a part of my environment. In this case, Active Directory domain makes sense. It wants to know which user account will I use to start the process of discovering this computer. The note points out that that user account needs to be somebody who is a local administrator of that destination computer. So I'm going to use the domain admin account. It wants to know which computers I'm searching for, and I'm going to start simply and just name one of my servers, Hyper-V host 1. And what we'll see as we roll forward is that the wizard's going to detect that that computer is out there and that it's part of a cluster. And therefore, it's going to want to add the other server and the cluster object as a whole. Yes, I want to include those servers in my environment. They're part of my cluster, Hyper-V cluster.globomantics.local. There's server 1, there's server 2, host 1, host 2. Neat. I don't need to remember the identity of all the servers that are part of my failover cluster. Picking any one of them is sufficient to add them to the SCVMM environment. It's letting me know here that it will install Hyper-V if it's not on those servers. In this case it is, so there's not a lot of worry there. Let me click OK. And it wants to know which host group I want to assign these computers to. There are tasks that I can perform to administer whole host groups, collections of hosts together in one collection. The all hosts host group, of course, includes all hosts. So we're prepared to go search for these 2 Hyper-V capable servers and add them to my environment. Sounds good. I'll click Finish. And the system begins performing tasks kind of behind the scenes. Ultimately, everything that SCVMM is doing behind the scenes through PowerShell. So if you haven't taken the opportunity to take a PowerShell class here with TrainSignal, it's wonderful stuff. PowerShell can be used to administer almost everything in the Windows Server 2012 environment. It's a vitally important enabling technology. So we can see here that we've somehow encountered some sort of a problem getting Hyper-V host 1 configured. Let me go ahead and close up my jobs window. And we can see that my interface is aware of the Hyper-V cluster as a whole. It sees Hyper-V host 2, and it identifies that it intended to add a computer called Hyper-V Host 1, but somehow failed to do so. So I'm going to take a second run at trying to add that server to the host cluster, specifying an appropriate user ID and password. And we seem to have got it that time. At least it looks that way. The best way to double check is to go visit my jobs area down here, and we can see here that SCVMM is trying to add server 1 to our environment. So we can see that we've successfully added the host this time around with information. If I click it, we can see the details that describe the potential problems and the concerns that SCVMM has about that. It's saying it doesn't see multipath I/O enabled. It's right. I've only got one way to get from one host to the other host in my failover cluster. That's a single point of failure, and SCVMM cares enough to recognize that that's a potential vulnerability. Having done that, I can go look at my list of VMs and services, and I can see that host 2 is currently hosting 2 VMs, one in a stopped state, one in a saved state. From here, I can right-click the virtual machine and perform all the kind of operations that I might otherwise do from A, the Hyper-V console, B, the Failover Cluster Manager console. But I can do things here that I can't do anywhere else, like take that virtual machine and store it in the library. The library is a home for virtual machines that aren't being used for a while. When I decide that I want them back, I can come back over to the library, which is managed over here off to the left, go find an object and return it back to a host. Also in the library are the blank virtual hard disk files that I might use for creating a standard small size, a standard large sized virtual machine. Virtual machine template configuration is here, identifying the ability to create a standard kind of virtual machine. Not saying we want to create those virtual machines yet, but that we intend to create some kind of virtual machine at some point. I create that either by basing it on some existing virtual machine template and then tweaking it, or taking some existing virtual machine, saying, yeah, I want to create a type of virtual machine that's like that one virtual machine over there. And I can, for example, go grab my failover demo VM and use that as a starting point. It's warning me that my current virtual machine becomes the template here. So if I'm concerned about keeping that, I may want to make a copy of it first. In this case, I'm going to go ahead and destroy it and create my template. The template gets a name, standard Globomantic server template, within which I begin defining the hardware settings that are going to be associated with that virtual machine's virtual hardware. I can use the default hardware configuration or create my own custom one. Having identified which hardware profile to use, I identify which type of operating system goes on this standard kind of a machine. Having picked an OS, we pick which library server we want to be able to store this on. We choose a path in which to store that VM. I'm going to put it in my library. And we're ready to create a template. When the time comes later to build a new virtual machine, I can say build me a new VM that's like that and reference my template. And now every VM that's created from that template will be, at least superficially, similar. That's going to make it easier for me as an administrator of a virtualization environment to apply the lessons from having troubleshot one VM to another, because they will all have been based upon the same basic baseline configuration. And of course, in some organizations, there'll be 2 and 3 and half a dozen different templates that are used for different purposes within that organization. All the other elements of my virtualization environment are described here by way of the SCVMM fabric, the description of which hosts are hosting my virtual machines, what kind of networking links those hosts together, and what kind of storage hosts the virtual machines that lie inside of those hosts. The combination of those together is what Microsoft calls a fabric, and I can manage my fabric, manage my hosts, manage my VMs, migrate virtual machines from one host to another, and in general, rationalize my whole virtualization environment from Microsoft to Citrix to VMware, all from one centralized console. So this has just been a quick introduction to what SCVMM is designed to do. We could of course spend a whole course just on nothing but SCVMM functionality and what you can do with it. But for the time being, I mostly want you to be aware that this tool is out there, and that it might be a valuable choice to help rationalize the way you do all of your virtualization from Microsoft to VMware to Citrix. I hope that's been helpful to you. I look forward to sharing more information with you in some of our other lessons.